Hi, everybody. My name is Randall. I'm a software engineer and developer evangelist at Amazon Web Services. What that means is you send all of your complaints about the services to me, and I give those to the service team, and then I somehow don't get fired, and eventually that gets turned into actionable feedback, and we iterate on that. As I'm sure you've heard a million different AWS people say before, 90% of our roadmap is customer-driven. So if you're having trouble having your account manager, your SAs get that stuff in front of the service teams, I have a direct line to all of them, despite not being in Seattle. I am supposed to give this talk today. I'm curious, what's the general level of experience with databases in this audience? So if I were to say you're a 5, you could write a scalable B-tree implementation from scratch in C++ with one hand behind your back. Anybody? Okay, and then who's like a 3, which would be I can mess around with SQL, I'm good with NoSQL, I know the differences. Okay, and then who's like a 1, LOL, what's a database? All right, well, this is intended for beginners. I can maybe tune it a bit to make it a little more up level. It seems like the gross majority of the audience is in that intermediate space. So I'll do what I can. Am I supposed to stand in front of this? Oh, okay, good. Little background about me. I have quit Amazon 3 times. This is, well, only 2 times, but talk to me again in a few months. I left the first time to do a startup, and that completely failed, and I lost all my money, so I had to get a real job again. And then I left the second time to go to a company called SpaceX, based in Los Angeles, California, which is much more beautiful than New York, which is where I used to live. And then I met my fiance there, and I just haven't left New York, LA, although New York still calls to me. With that in mind, Python is the most beautiful language in the world, and JavaScript is mass psychosis. So we're going to go through a quick history of databases here. Databases actually start before this little 1970 thing. If you think back to the first written words, those are a form of database. So you're taking information and running a very low fidelity compression algorithm on it, or very high fidelity, depending on how precise you want to be in your writing. It's like a Margaret Atwood or Hemingway joke in there somewhere. And you're encoding this information into a format that can be read again. So storage is kind of that first layer of the database, is you're storing information and then reading it back out again. Now, the way that people access information, the query patterns, the access patterns, determine a lot of where you're going to choose a database. So if you think about the 1970s, you have, in the early 80s, you have Oracle, DB2, SQL Server, and then you get Sybase and all the other weird ones that came out around then. And what happens is you are optimizing for storage. So everyone's heard of normal form, right? Where you extract out, you have these double foreign key relationships, and you're writing all these joins and all this good stuff. The reason that you do that in old school databases is because they were optimized for storage at the time, because storage was one of your most expensive resources, and it was also fairly slow. So you didn't want to duplicate data. You didn't want to be reading data from one long piece of information. You wanted to be able to kind of parallelize those queries and read from a couple different places if possible. And does anybody remember what the size of a 5 megabyte hard drive was in 1981? About the size of the table. So that's why you would optimize for storage. And there was one forward-thinking person in the 80s. Does anybody remember Edward Pick in the Pick database? This dude was, can I swear? This dude was batshit crazy. You know those upside down chairs that you use to stretch out your back or something? So homeboy takes 2 CRT monitors, welds them on to one of those chairs, and programs upside down in like 1985, and he builds the Pick database, which was a database for Apache helicopter parts. That was their only client, and then they failed. Much like the helicopter, no. And that was the first time that someone said, LOL, normal form, we don't need that. It's kind of, old school. Let's be new school, and let's just duplicate information all over the place. And it was a cool idea, actually, but the hardware at the time just didn't work. It wasn't, we didn't, the von Neumann architecture of the time did not scale to the point where the different buses that we had to go through to access storage, to access RAM, none of those really worked well enough or had enough throughput to do that duplication of data. So then we go into 1990s, where we have access. I would actually argue that that is not a database, but some people have told me I'm wrong. Pro tip, if you're giving this presentation and the former product manager for Microsoft Access is in the crowd, don't talk shit about Access. Especially if that person has access to a microphone and can begin to heckle you. So then we get MySQL, we get Postgres, and then there's a recession, or not a recession, but everyone is working on other things in the 2000s. Either you're making a ton of money selling diapers on the internet or some other weird thing, and then it crashes, and then those of us who were employed were too busy trying to keep our companies afloat to do anything other than make those companies stay working. And then in 2008, all of a sudden we start getting new databases again. Slightly before this, in the dark ages of what I like to call the XML era, there was a thing called MarkLogic. Does anybody remember that? Okay, you should look up the MarkLogic database, and you should look up the query language. And it's like you want to poke your eyes out afterwards. So then we get Cassandra, we get MongoDB. I was actually an early employee at MongoDB. I think it was like number 12 or 13 or something. And I got that job from a hackathon in New York City where the founder was there. And I was like, hey, I need a job because I ran out of money. And he was like, okay, come work for us. So I worked at MongoDB for a couple years. And then Redis, Elasticsearch, DynamoDB, Aurora. We'll talk a lot about Aurora. Neptune, we'll talk a little bit about Neptune. Timestream, I'll give you a brief overview of. QLDB, we'll talk about. And DocumentDB is just MongoDB, but on the Aurora storage engine. Okie dokie. So why do we have this explosion of different databases now? Why did we not have all of those other databases before? And I'll go ahead and say, we did have a lot of databases. The ones you see in this chart are just the ones that survived. It's kind of like evolution or natural selection. The ones that didn't succeed have kind of disappeared. Like, you don't see the PIC database on here, but the PIC database is really the precursor to something like MongoDB, a document store like MongoDB. But the reason we have this proliferation of different databases and different access patterns is that we finally have the commoditized hardware to build out really, really powerful designs. And modern applications have modern requirements. So instead of being able to serve 100,000 users, we are serving millions of users or hundreds of millions of users. Instead of terabytes, we're dealing with petabytes and exabytes. We want our data stored as close to our users as possible so we can serve it to them as quickly as possible. We're talking about performance in terms of microseconds in some cases now, as opposed to single-digit milliseconds. We have millions of requests per second. Snapchat, does anybody use that? I do because my niece got me into it, and there was this Coachella music festival, and I couldn't go. I don't really want to go because it's a lot of people, and like everybody's touching each other, and I'm just like, yeah, leave me alone. But I did want to see the Weezer set. So all I had to do was go on Snapchat, and I would like zoom in on Indio, California, and then I could just click through other people recording the whole Weezer set. And it was awesome. It was like being there without smelling and getting dust in your face. I promise I'm a normal human being. So Snapchat uses DynamoDB, and they deal with not millions of requests per second, but billions of requests per second. And they also scale up and down on top of DynamoDB. So if you think about New Year's Eve for Snapchat, how many different people age 14 to like 40 and other people who use Snapchat? I guess my grandparents do use Snapchat. That's weird. A bunch of people use Snapchat, so that you have this whole population of people who are using it, and they're all using it on New Year's Eve to record, the ball dropping or some other event. So the way that Snapchat works is over 24 hours, you lose access to that story. So you record it, and then it ages out after 24 hours. So DynamoDB has something called TTL collections. And with TTL collections, or TTL items, and you can say, I want you to age this out after a particular time. But if you think about the way that would work if you just had a static timeout, right? Now you're not just scaling up to peak load once, you're also scaling up to that peak load again 24 hours later. So TTL collections don't always work when you're dealing with billions of operations per second. What you want to do instead is have some sort of Reaper in the background running in a container or a series of containers that's going to go and set a random timeout 24 plus to 36 hours later. And it spreads that load out across the control plane. But what you can do instead is you can just modify one attribute of whether or not it's visible. Either client side or data side would be preferable, right? Because you prevent people from being able to hack their clients, and people like me who will download the binary, run strings on it, get the secrets keys, and then just, yeah, don't ever let me log into your Tesla account. So you get millions and billions of requests per second. You want to access things on the web. You want to access things on mobile, IoT, devices. You want to scale up. You want to scale out. And you also don't want to have to pay for idle. That's kind of a serverless deal. And then developers, which are our biggest market, I would say. As developers, we don't really want to mess around with a bunch of BS kind of weird connection strings and SRV records that we have to do for service discovery, and we don't want complex SDKs, and we don't want to have to build yet another ORM to deal with all of this stuff. We want SDKs that just sort of work. Like, hey, I want my data. So there are a couple broad categories. I've talked a little bit about these already, but on the relational side, we have RDS and Aurora, and then in key value side, we have things like Redis is a key value store, but it's also more of a cache store because it doesn't really have much of a persistence layer. Redis dump is the persistence layer of Redis. And then we have document stores, which MongoDB, which are the best. And then we have other in-memory stores, things like memcached, graph stores like Neptune. We have time series collections. This is going to be the time series database I'll talk about later. And then ledger databases, which are kind of a new-fangled concept, but an old-school problem that we used to implement in relational databases very poorly. So this is the whole map. There are a few things on here that you've probably heard of, but I'm not going to talk about today. So Redshift is not on this slide. Redshift is a database, but it's also a data warehouse, and it's also super expensive. So I don't talk about it that often because normally the people who can afford it have already gotten it. You can run Redshift Spectrum hella cheap, but if you want to keep a whole Redshift data warehouse around permanently 24/7, you're probably doing it wrong. The best way to use Redshift is actually to spin it up only when you need to run your reports and then just shut it all down again. It's pretty powerful when you do it like that, and it's actually really reasonable cost when you do it like that. And then everything is still cheaper than Oracle. Anybody work for Oracle? Okay, so I'm not going to poke any fun here. Like I said, on the relational side, you have relational database service. This is going to manage all your ops for you. It'll do the replication, it'll do the multi-AZ availability, it'll do the backups, it'll do security, it'll do all the good fun stuff that you're used to with RDS. It seems like we're all relatively familiar with that. Then we have DynamoDB, we have DocumentDB, ElastiCache, we get our choices of Redis or memcached, Neptune, Elasticsearch, managed Elasticsearch. Anybody ever run Elasticsearch in prod? So Elasticsearch is not really the issue, it's more Logstash. If you've ever had to maintain and keep Logstash up and running, so at SpaceX we built a whole system that collected metrics over a bunch of random TCP and UDP ports, sent those into Logstash, and then Logstash was responsible for running a couple transforms on them and getting them into Elasticsearch. Running a fleet of different Logstash instances was the bane of my existence. And you'll notice that we don't run Logstash with managed Elasticsearch at AWS. Then we have Timestream and Quantum Ledger Database. All right, so let's jump into each one. Like I said, RDS, easy to scale. This is what SQL looks like. I'm sure we've all seen this before. SQL uses a TCP-based wire protocol. The protocol itself doesn't really need to be sent over TCP. You could use some other format if you wanted. In fact, there's a lot of ongoing research or kind of cool development in that area, because if you think about the way that existing ODBC connection drivers work, is they're going to allocate a pool of connections, and then you're going to share that pool of connections through all the invoking clients, which doesn't work so well with something like AWS Lambda, where you have hundreds and hundreds of short-lived clients that are going to go and try and talk to this one database. So you're spending all this time spinning one connection up, spinning another connection down over and over and over again. So you want some sort of layer outside of that Lambda function that's going to do some of that persistence. And I would say, stay tuned. Few things in the pipeline. So it's very easy to scale up individual instances to, I would say, 64 terabytes or plus. Scaling out is not so easy, especially if you want to do multi-master. Scaling out with read replicas and kind of forcing your load onto those read replicas is very reasonable. If you want to do any sort of sharding, that has to be taken care of at the application level. So your application has to be aware of the fact that you're talking to a sharded cluster. There are things like PG bounce and other kind of tools that you can use in both MySQL and Postgres to abstract away a little bit of that. But when you reach that threshold, you're already running into other kinds of problems. So typically, I don't recommend that unless you really, really know what you're doing. And then joins. Good old joins, the source of most performance problems. Then we get into Aurora. So when we built Aurora, so there's this guy, Anurag Gupta. He actually left Amazon to start his own company. I forgot what it's called, but he was the VP of the Aurora database engine. And he and Debenajan and a couple of other people kind of got together, and they came up with this idea like, hey, these databases were last designed and built in LOL like 1980. Like, let's think about how we would design these in 2014. And so they looked at the commodity hardware that was available to them. They looked at the specialized hardware that was available to them. They looked at the networking switches. They looked at all this other content that was available. And they said, OK, what we're going to do, we're going to create a shared storage layer, which if people do this in real life, just to host WordPress servers, they'll create an NFS mount, and they'll point their SQL at this NFS mount. Don't do that. Like, let us do that for you. Because it is rife with different error and failure modes. And we've got 10 plus, almost 15 plus years of experience of running this kind of storage layer that a lot of other folks don't have, unless you hire people from that team. And what will happen here is you split the data up into a bunch of little chunks. You point the compute at that storage layer, that shared storage layer, so your storage is separate from your compute. So your compute can scale independently of the storage layer. And you get lots of replication. Everything is stored in a lot of different places. And it buys you a lot of different features, like point-in-time recovery. So you can roll back to any single transaction in the history of the database at any point in time for however long you're willing to keep that around. I think the default is 7 days, and then we go all the way up to 35 days. You can spin up a new node pretty much over the course of a minute. Even if it's a 64 terabyte database, it only takes the amount of time for the compute to come online to spin up. And it's not just the database itself. It's not just that pure storage layer. We're also shipping around the page files and the caches. So we can restore that stuff into RAM as quickly as possible. And then you have multi-region and multi-master. So you can have, because of that shared persistence layer, multi-master characteristics. And you can also do multi-region. And eventually, you could do both of those together. All right. So moving on from SQL, we can talk about NoSQL. I don't like the term non-relational because many NoSQL databases do have relational characteristics, and you can build complex relationships on top of them. But DynamoDB is kind of the canonical NoSQL store. So there was a Dynamo paper written in 2012, 10, one of those years. I don't remember. It's too much beer. So what happened is they wrote this paper, and then they implemented it in a completely different way and added in a few constraints, and then Couchbase went and did it in a different way, and Cassandra went and did it in a different way. But DynamoDB is interesting from a data store perspective in that you interact with it through an HTTPS API. And there's some advantages to this. So, for instance, who uses DynamoDB? 100% of the audience. For the purposes of any video, that was 100% of the audience uses DynamoDB. So, DynamoDB, throughout 2015 to 2017, completely rewrote their backend. So the entire service was rewritten from scratch in 2015 to 2017. And I'm just curious, any of those of you who use DynamoDB, did you notice that the entire thing had improved? So this allowed for a couple of different things. It allowed us to reduce prices. It allowed us to add many, many more features, many more features, and to build out a lot of kind of cool new stuff on top of DynamoDB. So this is what the data structure looks like. You have tables, which is probably familiar to folks from the SQL world. You have items, and then you'll notice something different from the SQL world. Instead of having columns that need to be populated and allow null and all this other stuff, the columns are sparse in that you populate these attributes outside of this columnar idea. This means you're not going to be writing any DDL to author column type or any of this other stuff. If you want to store a string in one attribute and a number in another attribute, you can do that. On top of that, you have this partition key. This is mandatory. This is what's going to split your data across the different partitions within the database. This partition key can also be paired with a sort key. And the sort key is how you're going to search through each partition to get the data that you're interested in. I've built a bunch of different things on top of DynamoDB, and this takes a little while to grok. It takes a little while to get to this idea of, I know exactly what my partition key is going to be, I know exactly what my sort key is going to be, and you don't even always need a sort key. If you're interested in learning more about how to model these relationships, Rick Houlihan has a really, really good talk. It's called DAT 403. It's from reInvent. He's given it every single year. And I would recommend the one from 2017 because the one from this year he spoke at like 55 miles per hour. And you have to put the speed on like 0.75x just to be able to hear what he's saying. But the one from 2017 was absurdly good. So 2017, DAT 403, Rick Houlihan, great talk if you want to learn more about DynamoDB and advanced modeling. And we talk about some use cases. So we bring on stage some people from Snapchat. We bring on stage people from a few other companies to talk about how they built and modeled their data in DynamoDB. All right, so you connect over HTTP, you get global secondary indexes, local secondary indexes. Very few people use the local secondary indexes. I would say the global secondary indexes are really just provisioned in the same way as your partition key. It's almost like a view that you're instantiating of the table, a different means of accessing it, and you can actually provision the capacity for those global secondary indexes entirely separately from the capacity for the original primary key. In addition to that, your read volume and your write volume are independent of each other. So when you're scaling DynamoDB, if you have a very write-heavy workload, you can make your write capacity units 100,000 if you want. If you have a very read-heavy workload, you can make your read capacity units 100,000, and then your write capacity can be 10. When you have those two that scale independently, it lets you be very flexible with how you build your applications. You get global tables, so these are multi-region, multi-master tables. One thing I will say is you cannot port existing tables to global tables. You have to start with an empty table. So add all the regions you want in the beginning. We just removed all of the additional costs for running these tables. So you still pay the data transfer costs, but you don't pay for any of the streaming costs for sending the data. So you used to have to pay for the DynamoDB stream, but we decided there is no reason for us to do that. You can now do transactions across multiple tables and multiple items within those tables. So I think you can have up to 10 different tables involved in a transaction. In Python, it's the exact same way you would do a batch insert or a batch get. It's with ddb.start transaction as t.put item, t.grab item, and you can just create that context, and then you can have a couple different failure modes from that transaction. You can say, I want everything to fail completely, or I want everything to fail a little bit, and you can get the old items, you can get the new items, whatever you want. It also supports this pay-per-request model, which is cool. This is great for workloads that aren't running all the time. So you don't want to have read capacity or write capacity provision 24/7. You can just flip it onto this on-demand model, and you can flip back and forth between these two modes within your tables. So you can flip it onto this on-demand model, and you can say, hey, on-demand model, I only want you to charge me per request instead of charging me all the time for my provision capacity. This is what a beautiful Python sample using Boto3 looks like. So we're going to say Boto3 resource, DynamoDB, table, votes, and then we're going to say votes, table, update the item. Our key is going to be the name of the editor. This is from a piece of code that I wrote to let people vote on their favorite text editor. The correct answer is Vim. And then we're going to say update expression. We're going to add to votes increment. And we could even add a conditional in there so that whenever somebody votes for Vim, it votes twice. Not dissimilar from American voting machines. Expression attribute, sorry. And then we define what this attribute value is going to be. It's going to be an increment of 1. We're going to have return values. It's going to be all new. We can add in a lot of conditions here. So we can say, set this if this condition. It's a very rich query language. It isn't like anything else that you've ever seen before. So, good luck. Lots of new features in the last 22 months. Global tables, an SLA, adaptive capacity, transactions, encryption at rest, DAX, DynamoDB Accelerator. This is the ability to put basically a cache server in front of your DynamoDB tables. Point-in-time recovery, on-demand. All kinds of good stuff has been added. People always ask me why backup took so long. DynamoDB supports virtually any size of table. So when we built backup, it had to work for the large companies of the world who have multi-terabyte tables the same way that it worked for my table of like selfie strings, which is 5 megs. Take a lot of selfies. And that is why it took so long. Like we could have built this and made it work on the small scale very early on a long time ago, but to make it work at that multi-terabyte scale took a long time because you're basically going up against the barriers of physics in some cases. So DocumentDB is what happens when you reimagine DynamoDB, when you reimagine MongoDB in 2019 on top of the Aurora storage engine. So what we did is we decoupled the compute and the storage layer, we distributed the data in much smaller partitions, and we increased the replication. This is literally taking MongoDB data in BSON or whatever format and converting it into these small partitions, just putting it across the shared storage layer, and then having the compute be responsible for farming it out to the different storage nodes. This is really, really cool. I am a MongoDB shareholder, so I don't know exactly how to feel about this, but I will say it is a testament to how completely awesome the MongoDB query language is. Because running MongoDB, I'll be the first to say, having run it in production and been on support teams that supported people running it in production, it is not the most pleasant experience sometimes. Sometimes it is. The query language, though, is unparalleled in terms of expressiveness and in terms of the way you put your data in and get your data out. I have yet to see something as elegant and good as the MongoDB query language. It takes 10 minutes to learn the whole thing, and you get your data out the exact same way you put it in. So let's say I have this document, and what is this? This is like a shopping cart. So if I wanted to query on any one of these nodes, I could. And MongoDB will adapt over time and learn what my query patterns are. So you can run an explain, you can run a hint, you can do all of the things that you would normally do to kind of give SQL a leg up and tell it what indexes to use. But MongoDB will also do that on its own, depending on how you're accessing things. There are a lot of good tools out there. There are a couple Python tools that will scan your slow query logs and tell you all the good stuff about, hey, you should add an index here, you should add an index here. It supports indexes like geo-indexes, aggregations. You can animate a Mandelbrot fractal using the animations. And if you want to do streaming stuff, I've done streaming video going through MongoDB and then transforming it, the pixels, into ASCII values and then outputting it over Telnet, which was the worst demo of all time because it's like a Rube Goldberg machine of insanity. All right, now we get into ElastiCache. We'll go through the rest of these real quick so we can get to some questions. Redis, pretty straightforward. It's a Redis serialization protocol, and this supports strings, hashes, lists, sets, and sorted sets. It also supports a couple of other newer features. And there are very few commands. You can learn all, I think there are like 110 different commands, and most of those are for weird edge cases. The core set of commands, they just operate on these features, and Redis is really great for building out WebSocket-powered applications because of these pub sub features. It supports clustering via partitions, but it's blind partitioning in that the application has to be aware of the fact that you're partitioned. Memcached is the same way, text and binary protocols over TCP, very small number of commands. I think this is all of them except for the statistics commands. You can add stuff, you can replace stuff, you can append stuff, and then you can delete stuff. And again, client blind partitioning. Memcached is used in a ton of different cases, most of the time in Django, WordPress, Drupal, like any of these apps that is going to make a bunch of database calls and you want to store the aggregated values, Memcached is a great way to do that because you can just hit Memcached instead of hitting your database, and you can even start the database transaction in another thread and then immediately serve to the client the Memcached stuff. There are servers, there are tools that are already built out there, things like WP Supercache that will do this automatically, and it just keeps the information up to date, make sure that you're managing your threads correctly and not killing your database. So when we talk about networking, graph databases, there's been this proliferation of new data that is richly connected. And these are edges that are not just, oh, he's my friend, or she's my friend. Those edges between the different nodes have rich data associated with them. Timestamps, it has queries, it has other, like we've been friends for this amount of time, and these are both calculated attributes and stored attributes that are stored on the edge, on the little thing connecting the two nodes. This is kind of a new way of representing data, and we used to represent this in a relational database with stuff like this. Does anybody remember these kinds of tables where you would have double foreign key tables related to another double foreign key table, and you would have, over here, the skill level would be yet another, reference into skill, and then that would have some data associated with it, and it just reached the point of insanity where whoever was responsible for managing that after you just did drop all from table, like forget it, it's not worth it, we're gonna get rid of this table. Now, the query language and the patterns that are available to you to kind of access this stuff are much better than they used to be. So Neo4j, I would say, is kind of the first company that really brought this to the forefront. I'm not a huge fan of their query language, but I do think their model for data was excellent. So Neptune is, again, imagine that kind of shared storage layer. Imagine that compute layer. Does anybody notice a theme here? And you're able to query billions of relationships with millisecond latency, 6 replicas of your data across 3 AZs with full backup and restore, powerful queries supported in both Gremlin and Sparkle. I'll talk a little bit more about those in a moment, and a Tinkerpop in W3DF. So property graph is the Gremlin traversal language. I think Gremlin is a much better language than this XML hellhole that is Sparkle. That said, I see way more Sparkle in the wild than I do Gremlin. And that's because Sparkle, I'll show you why. So this is Gremlin. I'm gonna skip over here. This is Gremlin. I wanna add a vertex, I'm gonna give it a property, I'm gonna give it a name, I'm gonna add another vertex. This is not true. This is not like saying I am single. What it's saying is that I am only adding, I'm replacing the age value. I'm not adding another value into the age array. So that's all that single indicates. And then we're going to add another person. We're going to add my friend Marcus, and then I'm going to say knows from vertex 1 to vertex 2. We're going to have a property weight of 1.0 because I know him really well. And then we're going to say has label person, and that'll give me all of the vertexes that have the label person, so it would return Randall and Marcus. And then we're going to say has name Randall, and I want to output a value map of all the people that I know. Or that know me. This is RDF. So RDF is stored in triples, or if you're drinking beer, a tripel. And you basically say what the schema is, you say what the data is, and then you relate those two. And then you write this absolutely absurd-looking query, and then this is the result that you get. So why do I see more of this than I do of Gremlin? I really have to sneeze, sorry. Or I guess I don't. It's the worst feeling. So you want to sneeze and you can't. Ah. So why do I see more of this Sparkle data than or RDF data than I do the Gremlin data? It's because that RDF data is universally identifiable. So you can take different data sets from different locations and different stores and locate them together. You can join them together. You can even make queries across different instances of these data, and you still have a unique identifier for all of them. And the schemas being publicly available in reference lets you be able to kind of discern value and information out of that data. All right, Timestream, still in preview. If anybody's interested, shoot me an email. I make no promises about my ability to get you into the preview, especially given the capacity constraints of like 10 million people sending me emails and asking to get into this. This is really cool. What they do is you have 3 tiers of data storage. You have one tier, which is your in-memory access to this data. You have the second tier, which is fast SSD. Third tier is going to be magnetic storage. That magnetic storage is going to be the slowest tier. You can write different transforms for the data at those points in time. So as you transition between those 3 storage tiers, which are priced at different points, you can say, when I go into this magnetic storage tier, I want to bring the data down into, say, like a smaller format. I don't need to store every single point. Or maybe you do want to store every single point. It's really in your control. You can do functions for interpolation and smoothing and approximation. And again, it's a kind of a serverless interface. Okie dokie. Quantum ledger database. This is something, again, that people have built before on top of relational databases, but it's complicated because you have this ongoing transaction log. It's essentially a append-only journal. It's an append-only cryptographically verifiable transaction log of what has happened on this item or on this set of items. And if you implement this in a relational database, eventually you run into the problem of, hey, this person has been alive for 170 years, and we're still adding more and more transactions. And why won't they just like give up already so we can let this item age out? And I guarantee you, like when someone discovers how to make people live a long time, all these different databases are going to start failing. Because they're just going to be like, we can't render your health record because we don't have enough RAM. This is very cool, and there are a lot of different use cases for this. I'm not going to talk too much about them, just given the time constraints, but if you're interested in learning more, there's a video series that I start every Tuesday, next Tuesday, where I'm going to be interviewing a bunch of engineers and customers from around AWS, and we're going to just dive deep on each type of database. So the 23rd and every Tuesday after that, for the foreseeable future, I will be in Seattle, locked in a room with a bunch of old school principal engineer folks who are really nerdy, and we're just going to nerd out about databases for a solid couple hours. Migrating databases is great. You can do this with DMS. It will manage it all for you. These are great animations. How do people use these in real life? Verizon is moving all their stuff into Aurora. Amazon, of course, has just shut down their last Oracle data warehouse, and there's still a couple different Oracle databases running, but more than 97% of the companies migrated off of it. One thing I will say is the move to Athena and S3 has made my life easier because I used to have to use Oracle BII. Has anybody had to use that tool? The smart DLL and okay. It's frustrating. It's very slow, and it just doesn't deal with saving and remembering queries, so you have to rewrite your query from scratch every time. Now, I just define a view in Athena, and I immediately access all my data, and I get nice little pretty charts, and I can adjust little things without having to rerun everything every time. Lots of different customers using this stuff. iChart, this is like required in every single AWS presentation, right? Lots of customers. All right, thank you all for your time. I think that we have beer and things, or it's lunchtime, right?
We got time for questions if you want.
Okay, sure.
Take any questions? Who has questions for Randall? Oh, let me come over here.
So could you explain a little bit more the difference between DynamoDB and DocumentDB?
Yes.
From what I saw, we were seeing attributes on DynamoDB and the JSON objects on the other. I'm not sure when a company would use one versus the other.
Right. So when you query DocumentDB, you can query on any attribute, and it does not necessarily trigger a table scan, regardless of whether or not it's indexed, because DocumentDB is constantly calculating statistics about the various columns, various attributes in the background, and the engine is intelligent enough to allow you to query on all of those things without having to use an index. Additionally, you can index on any single field, and you can also make that index sparse, which would take much less space than provisioning a global secondary index would take within DynamoDB. DynamoDB, the only way you can access the data, the only query mechanism that's supported beyond a table scan is that partition key. So you have to use the partition key in your query. Otherwise, you have to look at every single item. So the difference is DynamoDB is much more of a key, I don't want to say key value, it's more of a key blob store, and DocumentDB is much more of a document store. So it supports a much richer set of queries and aggregations and a number of other features that are just not available in DynamoDB. Does that answer a little bit? Okay. I have a whole episode about this on May 6th.
I was just wondering, you mentioned joins with relational database,
Yes. Hi.
and I was wondering what kind of support the other databases, the other data management systems have for example, DynamoDB or the DocumentDB.
DocumentDB 3.6 does not really support joins. So MongoDB in 4.0 implemented joins. Our goal is obviously to get there. I will say the current implementation does not really support it, but it's a matter of time, not a matter of technical infeasibility. The DynamoDB side, you can do transactions, but when you're talking about joining data from multiple tables, it's really your application that's responsible for doing that. It's not the database or storage layer itself that does those joins. If you need to represent the data in another format, I have seen people create entirely separate tables and store and basically represent the data that way. So if you remember, I said NoSQL does not mean non-relational. So you can define relationships between different DynamoDB tables, and many people, in fact, do this. It's just that your application becomes the layer that's responsible for implementing the changes and implementing the constraints instead of the database being responsible for enforcing those. Because, like, you know, in MySQL, you would say ensure double foreign key, or ensure foreign key attribute not null, auto increment, and you're always going to be able, it won't let you delete an item from one table if you still have that foreign key referenced in the other table. So those constraints are enforced at the database level in relational databases and SQL-based databases. In DynamoDB and DocumentDB, it's all done at the application level.
All right, any other questions, Randall? All right, one more.
Thanks for your talk today. So how do we watch your videos on Tuesdays? How do we find that?
Twitch.tv/AWS. I started this channel in 2016 with zero budget, and then it was successful, so they took it away from me and added a lot of money to it. I don't have Wi-Fi, but it's just twitch.tv here. /AWS. Every Tuesday, starting on the 23rd, we're going to be interviewing a bunch of famous people in the database world, which is just like the coolest part of my job.
Awesome. Any more questions for Randall? Well, if not, let's give him a big round of applause.
Thanks.
Thank you for coming out.